Okay, so we're going to look at lesson 9.5, which is about properties of logarithms. So there's some basic log rules. So the first one is that log base b of 1 is equal to 0. What that means is that it does not matter what the base is. If you're taking the log of 1, it will always equal 0. The next one is that the log base b of b is equal to 1. So when the base and the base are the same, it'll always equal 1. So for example, if we have log base 4 of 4, that will equal 1. The next one is one that we have seen before. The log base b of b to the n is equal to n. So this one is saying that when the log base and the exponential base are the same, it will be equal to the exponent. So for example, if we have log base 3 of 3 to the 5th, it will equal 5 because that's what the exponent is. The next property is that log base b of x times y is equal to log base b of x plus log base b of y. So what this property shows is that if you are multiplying two things together in a single logarithm, you can expand it to multiple logarithms by applying a logarithm to each thing that's being multiplied. Since we're multiplying x and y, we end up with log base b of x plus log base b of y. It can also go backwards, where if you are adding two logarithms together, you can condense them to a single logarithm with multiplication. So for example, if I have log of 5 plus log of x, since I'm adding the two logarithms together, I can condense them to a single logarithm by multiplying the 5 and the x. So it becomes just a single log of 5x because I can bring them together using that multiplication. This same thing is very similar in the next property where we have log base b of x over y is equal to log base b of x minus log base b of y. So this time we're dividing. When we're dividing, we can separate them out into subtraction, or you can condense multiple logarithms into a single logarithm by using division if you are subtracting logarithms. So again, for example, if we have log of 7 minus the log of 5, this will end up equaling the log of 7 over 5. It's just a single logarithm, and I divide 7 divided by 5, the first number divided by the second number, or if it were a variable or expression, the first variable or expression over the second one. The last property that we're looking at is that log base b of x to the m is equal to m times log base b of x. So what this is showing is that an exponent can come out and become a coefficient. So you can instead multiply a logarithm by that exponent by making the exponent a coefficient. So for example, if I have log of x to the 5th, this will equal 5 times log of x because the exponent becomes a coefficient. So let's go ahead and look at some examples. So we're going to look at number 1a, where we have log base 4 of 2 plus log base 4 of 32. The first thing we want to do is to condense this into a single logarithm. So according to this up here, since I'm adding the logarithms, I'm going to bring them together with multiplication. So I'm going to multiply the 2 and the 32. So this will become log base 4 of 2 times 32, which ends up equaling log base 4 of 64. Now we have to kind of remember that 4 to the third power is equal to 64. So this will then become log base 4 of 4 to the third. And then again, using the property up here, where if you have the base, the log base, and the exponential base are the same, it's equal to the exponent. So therefore, since my log base and my exponential base are the same, it's equal to 3. So that means that log base 4 of 2 plus log base 4 of 32 equals 3. Looking at example B, we have log base 2 of 80 minus log base 2 of 5. So again, we're going to condense this to a single logarithm. Since we are subtracting, when we subtract two logarithms, we end up dividing. So I'm going to end up dividing 80 and 5. So we'll end up with log base 2 of 80 divided by 5. So it's just a single logarithm, and I'm dividing the 80 and the 5. So 80 divided by 5 is 16. So we end up with log base 2 of 16. Again, we kind of need to remember that 2 to the 4th power is equal to 16. And I go to 2 because my log base is 2. So I'm looking if there's a way that I can turn 16 so that it also has a base of 2. So that way we can, again, use this property right here. So what I'm going to do then is I'm going to substitute 2 to the 4th in for 16. And we end up with log base 2 of 2 to the 4th. And then again, because my log base and my exponential base are the same, it'll end up equaling the exponent, which is 4. So then log base 2 of 80 minus log base 2 of 5 is equal to 4. Looking at example C, I'm going to actually simplify log base 2 of 8 first. So again, I'm using that same property where I want the log base and the exponential base to be the same. So if I remember, 2 to the 3rd power is equal to 8. So I'm going to replace the 8 with 2 to the 3rd. So I end up with a negative 1/3 times log base 2 of 2 to the 3rd. Again, since my log base and my exponential base are the same, it's equal to the exponent. Therefore, we end up with negative 1/3 times, and then this guy right here evaluates just to the 3. So it ends up being negative 1/3 times 3, which ends up equaling negative 1. So then the negative 1/3 times log base 2 of 8 ends up equaling negative 1. Looking at 2a, I have the log of 40 minus 2 times the log of 5. So what we're trying to do here is we're trying to condense these into a single logarithm. The first thing I want to do is I want to make this 2 become an exponent on the 5. Because according to this property here, when you are multiplying a number by a logarithm, we can move it to be an exponent. So this will become log of 40 minus log of 5 squared. I can simplify 5 squared, so this would become log of 40 minus the log of 25. Then because I'm subtracting, when we are subtracting two logarithms, we end up dividing. So we end up with log of 40, because it's the first number, divided by the second number. So the log of 40 over 25. And then I can simplify that fraction. I can divide both 40 and 25 by 5. So I end up with a log of 8 over 5. And that is my final answer, because that's rewriting it as a single logarithm. So looking at 2b, I have log base 2 of 3/5 plus log base 2 of 5/2 minus log base 2 of 3. Since I have 3 logarithms that I'm trying to condense to a single one, we only are going to do 2 at a time, and we're just going to move left to right. So I'm going to deal with the first 2 first. Since I'm adding, that means I'm going to multiply 3/5 and 5/2. So I end up with log base 2 of 3/5 times 5/2 minus log base 2 of 3. Then I'm going to simplify that, and I'm going to multiply 3/5 times 5/2, and I end up with log base 2 of 3/2 minus log base 2 of 3. Now, since I'm subtracting, I'm going to divide, and it's the first number divided by the second. So we're going to have log base 2 of 3/2 over 3. And we can't have an improper fraction like this, so I have to simplify 3/2 over 3. So this ends up being the log base 2 of 1/2. And that is my final answer.